I am so excited for this. I have a quick lesson on cryptography. Let's start broad strokes. When we build a wallet, whether it's a MetaMask, one of these Coinbase wallets, or some magic link generates a wallet for us that holds funds for us, what we get with these wallets is we get a public key, we get a public address, and a private key. Well, really, we get a public key and a private key. What happens is the public key gets hashed to a public address. This is that OX, all that change that we see with these Ethereum numbers. Here's an example of a random address. This is just randomly generated. So these numbers are not to any real wallet. This is all just generated on a local server environment. But we get this public address, and this is what everybody has access to. You can send funds to, you can check if they did a transaction or something, you can check with this public address what it is. But how it works is, if everybody could send funds just because they had a public address, that would be a huge problem. So how it's split was there's a public key and a private key. And how it works is if you want to send a transaction from this public address, so let's say we're this first address, call it address 1, you have to also have the private key from that address. If you don't, you should not be allowed to send the transaction. That makes sense. If I own the wallet address, I should have the private keys and the public keys, because everybody has public key, but only I should have the private key. So what happens in a transaction is we sign the transaction with our private key to, one, verify that, one, we are the wallet owner, and two, we don't actually put the real private key here. It's a digital signature, which is basically another hash in a sense with the transaction. And what this allows is other people can then verify down the road if I really sent a transaction with my signature. People down the road can unhash the digital signature, which is really just going to be my public address, and verify that I sent the transaction or that it came from my wallet. So this is kind of a lot of broad strokes, but I've broken it down into a few steps to hopefully kind of break things down. So on the right here, we just have some hard-coded imbalances with accounts, and we have some private keys that were generated with these public keys or these public addresses. So how it's going to work is I'm going to take this public address, and step 1, we can check for the wallet address, and we can see the funds in it, and you can see I've appended a few things. This person, I don't know if they're the owner yet or not, but what I can do is I know for sure that someone has the public key, but everyone has the public key. Now, the only way, if I want to send a transaction, let's choose a second address. So here's the recipient address. You can see at the end it's 52C, just a different address, and this one's 8DE. If I want to try to send an amount, I get an error here saying you are not the owner of the wallet, so I can't do the transaction. But if I pull in the private key and say go ahead and paste it in, boom. Okay, so see, when I place in the private key, that this feature right here lets me know that I am the wallet owner. So I'm hashing the private key, throwing it through a Cache 256 hashing algorithm from the SHA-3 family, and I'm checking it against the public address to verify that I am the owner of this wallet. So now if I want to do something, I want to make a message, hello, this is a transaction, and I want to sign the message, I'll get a digital signature, and then what I could do is verify this would be the equivalent of me sending a transaction at this point. And if I'm a public person and I want to verify that this wallet did in fact send this message or sign this message, what I can do is put in this signature address. So basically, if I'm one of these random people just looking at the blockchain, before this transaction gets hashed to the blockchain, I can say, did this person really do this? Did this wallet really sign this? And I can go ahead and verify that this person did actually sign this transaction because it has all this data in it. Now, if this was off, let's say it's a different wallet address, even by one letter, if I verify the signature, you can see I don't get any verification. There's no alert message. There's no indication that was in fact the correct wallet address. But if I go ahead and give it the correct one, I get signature verified as true. That wallet address did actually sign this transaction. So if I've done everything correctly, I should be able to send a wallet address. So we'll send an amount of 10 units, transfer successful, boom. And you can see that the balance gets changed. And then we can actually go ahead and check the balance for this wallet address now. And you can see that this private key is not the owner of this wallet address, but we can in fact see the changed balance here. That's a lesson on cryptography, folks.